Here the question is, find the electric field vector at P, A, due to three infinitely long lines of charge along x, y and z axis respectively. The charge density, the charge per unit length of each wire is lambda. So first of all, here I would like to explain the formula of infinitely charged long wire. Suppose here this is a infinitely charged long wire having charge density lambda, and there is a point here, say P, at a distance a from this wire. The perpendicular distance from the wire, this point is P. Then electric field due to this wire will be along the perpendicular to this line charge, and its magnitude would be lambda divided by 2 pi epsilon naught A will be the net field due to this charge on this infinitely line charge. Okay. So one thing that you can notice here, that electric field is perpendicular to the wire. So let us first select a wire which is kept along the x-axis. So what should be the perpendicular distance from this point? If we join here this point, then we know that this is the perpendicular distance between x-axis and this point. And what is that perpendicular distance? A square plus a square, that means a under root 2. So here in place of a, let us write it to be d just for some time, so that in all these three cases d is going to be what? D is going to be a under root 2. So a under root 2 is the perpendicular distance of this point from these three wires which are placed along x, y and z axis. And electric field is perpendicular to the wire along the line joining this particular point to the foot of the perpendicular on the wire. That means if we look at this diagram along the x-axis, then this particular wire, x wire, will seem like a point, and here will be the point P at an angle 45 degree with this line. So electric field, since it is along the perpendicular bisector and away if we consider the charge to be positive, then there are two components of this electric field. Okay, this angle is 45 degree, so both the components are what? E by root 2. E by root 2. Okay, let it be E dash due to a single wire, then E dash by root 2 and E dash by root 2. And what will be the direction? One component will be along the y-axis and the other component will be along the z-axis, that you can see here. From x-axis, the electric field is here, and if we resolve, then one component will be along the y-axis and the other one will be along the z-axis. So from the x wire, we have two components. One component along y and one component along z-axis. So similarly, from the z-axis, we'll have two components, one along the y-axis, one along the x-axis, and similarly from the wire kept along the y-axis, we have two components. One is along x-axis, the other one is along the y-axis, and each component, what is the value of each component? E dash divided by root 2, and E dash is what? Lambda divided by 2 pi epsilon naught d, and d is a under root 2. D is a under root 2. Then what happens? E dash by root 2 means 1 by root 2 is here. So the one component due to each wire is going to be lambda divided by 4 pi epsilon naught a. So this way, x, y and z components, there are two pins. X is providing one y, one z. Z is providing one y and one x. So each I cap has got two parts, lambda divided by 4 pi epsilon naught a and one more lambda upon 4 pi epsilon naught a. So it becomes lambda upon 2 pi epsilon naught a, and same goes for j and k also. So option B has to be the correct option to this question. Okay.